So we have partnered with Business Finland to bring some of the expertise from these organizations and to share with you their technologies and their solutions. So during the webinar, hopefully you can all hear me now. You have the questions section on the side where during any of the presentations you can let us know if you have any questions for the speakers, and we will address these in the Q&A session at the end of the webinar. So after the webinar, next slide. So we will share a recording of the presentation, and we'll just ask that you complete the exit survey once the webinar is concluded. So next slide, I'll just run through the agenda for today's webinar. So we'll begin with my colleague Jason John is going to give a short introduction to some of the work that Emirates Green Building Council has been doing on indoor air quality and some of the challenges here in the UAE. We then have 3 expert speakers from Finland. We have Mr. Amo from the VT Technical Research Centre of Finland, Ms. Irma, Senior Business Analyst at the Helsinki Business Hub, and then we have Mr. Antti, who is a Senior Research Scientist at the Finnish Meteorological Institute. So I give more of an introduction to each of the speakers. I'm now going to hand over to my colleague Jason, who's going to give you a short introduction to this webinar.
Hi, thank you, Lindsay. So yeah, as Lindsay mentioned, we, the Emirates Green Building Council, have been doing some work as well on promoting the indoor air quality for the existing buildings here. So I'm just going to give you a brief overview of the work we've done as part of improving indoor air quality here in the UAE. So, okay, right. So I'll start with the project that we have signed on to with the World Green Building Council's Better Places for People. So the World Green Building Council's Better Places for People is a global program which aims to support the green building councils and their members to increase the demand and supply of green buildings, which are supportive of health, well-being, productivity, and the people within them. So as part of the Better Places for People, there are a number of publications which includes building the business case for green and healthy buildings. And now they're currently working on beyond the business case, where they're tying in net zero buildings and healthy buildings together. What are the cost and financial implications to them, and what is really the business case for merging both these ongoing global trends as for net zero decarbonized buildings as well as healthy buildings. As part of our project commitment as well, we are taking part in the Plant a Sensor campaign under the Better Places for People, where we are continuously monitoring the indoor air quality of our offices here in Dubai and providing that data directly on a public platform. Moving on to our next work. Just to give you an overview of the regulations and code that we have here in the UAE. There are a number of different building codes which varies from emirate to emirate. And in this, as you can see on the left-hand side, it is looking at the Dubai Green Building Regulations and Specification, which is the green building code here in Dubai. Which has predefined limits for indoor air quality parameters such as formaldehyde, TVOCs, and carbon dioxide. There are also ventilation requirements both in Dubai as well as in Abu Dhabi, which is related to the Estidama Pearl rating system. So as you can see on the right-hand side table, there are requirements for ventilation rates, filters, separation distances, and of course, the threshold limits for predefined chemical concentration values. So following on from our work in trying to increase the awareness related to indoor environmental quality, we held a roundtable in 2018 in trying to find out what specifically are the challenges as well as the opportunities related to increasing awareness. And it was a general consensus by the key stakeholders, which included government, schools, parents, as well as the private sector, that there is a general lack of awareness on the topic as well, and that more efforts are required to improve the indoor environmental quality. one of the key takeaways from that roundtable was the need to establish more data to establish a baseline for indoor air quality within existing buildings here in the UAE. More recently, a study that came out, I believe, this week or last week, showed that majority of the UAE residents are still unaware of the severe health implications of poor indoor air quality, which is quite significant considering that the World Health Organization says that the indoor and outdoor air qualities are one of the major risks of leading death in the world. So, as a part of the takeaway point from that roundtable of establishing the need for more publicly available indoor air quality data, we partnered with one of our corporate members, COMPETENCES UAE, to measure and evaluate the indoor air quality parameters of a representative school here in the UAE. We also evaluated other indoor environmental quality parameters such as acoustics, thermal comfort, and lighting as well. One of the main objectives, of course, was to identify further areas of research and improvements, and as well as outline a clear call to action to our diverse stakeholders on the um, the actions that you can take in improving the indoor air quality. So the overall project overview was took about a year and a half, in which we had stakeholder roundtables. We used our pre-existing publication, the State of Our Schools report. We had a team from St. Cobain who had gone to the representative schools and measured and to analyze and verified the on-site data and the analysis of the indoor air quality, as well as the other environmental parameters that I mentioned before, as well as doing our own market research and establishing what the general consensus is regarding indoor environmental quality as well. All of these fed into our report, Making UAE Schools Healthy, which also made us state a clear call to action related to improving indoor air quality. So we made a call to action to the various stakeholders, starting with the governmental and policymakers, manufacturing suppliers, green building designers and consultants, parents, schools and staff, the school and school facility management, as well as the other NGOs and research institutes. So there's quite a bit of call to actions. I'm not going to go into a full detail of all the diverse representative actions that we outline to each stakeholders, but I do encourage you to go onto our website and read our publications and understand what are the needs and the requirements for each stakeholder to promote indoor air quality within the UAE. So that's it from my side. Thank you, everyone, and I hope you enjoy the rest of the presentations that we have today.
Great, thank you very much, Jason. So let me introduce to you the first of our expert speakers. So Mr. Amo is the senior scientist at the VTE Clean Air Solutions. He's the head of the research group, Aerosols and Climates. He has fifth. Sorry, apologies there. Okay, so Mr. Amo is the senior scientist at the VT Clean Air Solutions. So I'll hand over him to deliver his presentation on technology as an enabler for world-class IAQ. Over to you.
Thank you very much for your kind introduction, and I'm really happy to join this webinar today. I will be talking about indoor air quality and clean air solutions. I have to say that they are definitely my favorite topics. I have been working at VTT for 25 years now, and my research topics has been ventilation, filtration, and air cleaning, and of course different pandemics already during the SARS-1 pandemics, but now we have this more serious one running at the moment. Can we get the next slide somehow? Thank you. So I just wanted to give you some picture about Finland to start with. As you probably know, Finland is located in northern part of Finland, and I think Finland is famous of midnight sun. During the summer, we have a light all the day and night. In the winter time, we have polar lights, and of course, we have thousands of lakes and snow in winter time. Temperature varies a lot during the year. We have these 4 seasons, and about Finnish people, during some international surveys, they have figured out that Finland is leading information society in the world. We are least occupied country. We are the happiest. The people in Finland are happiest in the world, and we are also most equal nation in the world. And we have also high education. This figure is quite old, but it illustrates how many people in Finland are scientists or engineers. And you can see that the portion is very high, and it also correlates to the money which is used for R&D purposes in our country. But we are quite small country. That's also because this figure here is quite small. The size is is compared to the size of the economy of Finland. The actual content of my presentation today is dealing with VTT and air quality issues. Of course, I will introduce shortly some clean air solutions and some experiences we have learned in field tests we have been running. And at the end of the presentation, I will summarize some of the most important lessons we have learned. First about VTT. So VTT is a technical research center. It means that basically the only thing we are doing is research. We will do it as a service for companies and societies, but we don't have any other products. So we don't have any concrete products. We always do cooperation with companies if we are talking about products. We are owned by Finnish government, which means that we are non-profit organization and we are impartial organization. It's good to remember that we are impartial in many cases. It's important. We are also quite big if we compare to the size of our population. And the role, sorry, you can take the next one. The role we are active is actually applied research, which is located between basic research, which is done by universities, and product development work, which is done by industry. Of course, we have close cooperation to both directions, but this is how we see that we are located in this research field. Smart city is quite a large topic. We have, of course, many projects related to smart city constructions and design issues. Unfortunately, we don't have time to go all of these through. I just wanted to point this one out because at VTT, we see that indoor air quality is definitely one and also very important part of smart city. So that's why I think we should be able to connect all our actions we do for indoor air. We should be able to connect these actions to this smart city framework. About our team, it's called Clean Air Solutions, and we are dealing with airborne contamination control. Of course, indoor air quality is important. We have been doing a lot of work to reduce this fine particle exposure control for PM2.5. Air filtration is very important tool when we want to reduce the concentration. We have studied mechanical, electrical filtration techniques, cabin air filtration, power plants, things like that. We are also doing this flow simulation with CFD. which actually Antti will present more about this topic later, so I won't go to the details in this topic. And we are also dealing with different measurement and monitoring technologies. And I would like to say that in any cases, we basically try to improve the situation somehow. That is important for us when we do these interventions. This slide is actually illustrating the reason why we are doing this work. I think this is taken from Harbin, China, a couple of years ago. You all can see that the concentration is quite high. I recall it was something like 2,000 micrograms per cubic meter or something like that. But you can see that the visibility is really, really bad. And it has been stated by WHO many times that air pollution is dangerous for human health. And that is actually the biggest motivation for basically everything what we are doing, because we want to reduce this health risk for people. And this slide is actually borrowed from medical doctors and epidemiologists. I like this illustration because they have illustrated this health effect, this adverse health effect by a chain, which is starting from emission and it's ending to health impact. And this is actually quite equal way to illustrate the chain, because basically you can stick to any box you would like. And it's also important to understand that if you manage to cut this chain at any point, you have actually solved the whole problem. And of course, our topic or our box here is this human exposure. We want to reduce the concentrations, what people will see or experience, especially indoors. And that is the area where we are active. And of course, as we spend 90% of our time indoors, it's reasonable that we start with these indoor air quality issues. It has been stated that 40% of the buildings suffer from some IAQ issues. It's quite a large number, I think. And there has been made also some calculations how much money is lost because of poor indoor air quality. Also, energy question is important since we are talking about ventilation systems. Buildings consume quite a lot of the energy in societies, and the part of the ventilation is quite high. So we need to design this ventilation system in an energy efficient way, of course. And also we must consider this energy consumption if we want to use these recycling room air cleaners. One way to illustrate this indoor air quality issue, and especially this money side, is that if you think normal office building and how much it takes money to run this office building, you can see that only 1% is coming from energy costs, 9% from rental costs, and 90% of salaries. And if you want to do something better, you can imagine 10% improve in some of these three topics. What is the result? You see that if you are able to improve the performance of the people by 10%, you have actually saved 9% in your financial result, and that is quite a lot. So I think it's important to understand that it's not only health, it's also money issue. There are some correlations which has been found between ventilation rate and people getting sick. And this is important to understand that the more the people inside the building are sick, the less they are doing the work and the less you will earn money. So that's why I think it's important to arrange this ventilation properly. It's not only getting sick, the ventilation rate also affects on the performance in office work. You can see that especially if this airflow per person is going really low, the performance is going down. Of course, if you improve this, increase this ventilation, you get better and better performance, but I guess there is some limit because it will steepen in larger ventilation rates. The similar figure can be found also for learning results in school. This is done by some mathematical tests, I think that, and this is illustrating the speed that the students can solve these mathematical issues. And so you can see that there is actually quite good correlation between these learning results and ventilation rates. So it makes sense to take care of this ventilation. So we are indoors and we figure out what you can find around us. Outdoor pollution, ventilation system, some emissions indoors, some leakages, things like that. But the conclusion here is that if you arrange this ventilation and filtration air cleaner issues properly, it's actually quite convenient way to achieve this health and good indoor air quality. This one illustrates particles which can be found from indoors. In European level, they have found out that more than half of the particles which are found from indoors is actually originated from outdoors. So the first thing we must do is to figure out how to stop the outdoor pollution to get indoors. And then we are talking about ventilation system. This one illustrates the ventilation system in one school building in Finland. I think that the specialty here is this heat recovery unit, which actually recirculates energy from exhaust air to indoor air, to supply air, and there are also, of course, filters installed, and this is the system how we actually measured the efficiencies of the filters. And what we found out, the efficiency of the supply filter is illustrated on x-axis. It's actually filter penetration, which is opposite to efficiency. And on y-axis, we have indoor-outdoor concentration ratio. So we basically measured concentration indoors and outdoors of the building. And these red dots, they are different filters with different efficiencies. And you can see that the correlation is almost perfect. So we can conclude that if you want to get rid of these ambient air particles, the best thing you can do is to use high efficiency supply air filters, because it correlates to the concentration indoors. Of course, you can also use these recirculating room air cleaners. This is a couple of hours period when these devices turned on and off, and you can see quite a nice shape of the curve. The indoor-outdoor ratio goes up during this room air cleaner is turned off, and when it is turned on, the concentration goes quite nicely down. So it's efficient, but it has to be dimensioned properly, because if you have a big building and small cleaner, it's not good. So you should have high capacity for these room air cleaners in big spaces. This one is one field test we have been running a couple of years in China, in Finnish Embassy Residence Building in Beijing. We designed and installed a new electrical supply air filtration system. And on the right-hand side, you can see that the original filter efficiency for smallest particle size we measured was something like 50%. And when we installed this new system, the efficiency is almost 100%. And at the same time, we actually reduced the pressure drop from 60 pascals to 30 pascals, which means that we save half of the energy which is used for filtration. We have also developed one innovation which recirculates the indoor air and it's connected to supplier terminal. You can see some illustrations here. And with this combination of supplier filter and this air cleaning supplier device, we have actually get quite good results. Yeah, here you can see how much the concentration indoors is decreased since we turn on the filtration in recirculating air in the room. And the main issue here is that this device doesn't have any fan, so it doesn't generate any noise. We are only utilizing flow which is generated by air handling unit, and it actually induces the secondary airflow indoors, and we filter this secondary airflow. That is the basis of this innovation, and it's actually being commercialized at the moment. Then about this corona, it's important to understand that all these techniques are also valid for reducing the effects of pandemics like COVID-19. There has been many guidance like REHVA, European Federation of Heating, Ventilation, Air Conditioning Associations have published quite nice guides, and so maybe you can find them on internet later. And maybe the last figure here is about local ventilation issues. This example is taken from industry, and on top left-hand side is the basic situation. We have only general ventilation, 400 liters per second. We have designed different ventilation solutions, local ventilation solutions, local exhaust, local cleaner supplies, and I guess the best result is on right-hand side down. So you can see that this concentration reduces very much, and this is, I think it's very promising because it gives a good understanding for us that we can actually do something for reducing these concentrations, and to my understanding the same is actually applicable also to these COVID issues as well. Then I brought up something which is most important issues why I think that we should invest to good indoor air quality. Of course, we can guarantee health and clean air, productivity and comfortable environment for occupants. Of course, that's for sure. We are able to stop ambient pollutants to penetrate indoors. We can use room air cleaners to reduce the concentration indoors. We must guarantee enough ventilation to make sure that this human performance is okay indoors. At the same time, we need to minimize these energy consumption issues, which is used by HVAC systems. And at the last line, I think that it's important to remember that this indoor air quality correlates also with economy. So it's not just for health, it's both health and economics. And how to proceed, I would say that it's important to understand that in Finland we have many companies who are actually forerunners in this indoor air quality technologies. The products are based on long-term R&D cooperation between research institute and companies. In Finland, we have a strong public-private partnership, which is actually one way to bring forward these products. VTT is happy to provide R&D services if you are willing to discuss about these issues. And we have also this indoor air quality ecosystem in Finland, which presents several companies who provide these products and services which is related to indoor air quality issues. And I know that many actors are actively seeking for partnerships in global markets. So if you have something in your mind that we could do together, I will be more than happy to continue the discussions. But at this point, I will end my presentation now. So thank you very much for your attention.
Thank you so much for that really informative presentation. As I said, we'll be taking questions at the end of the session. So if the audience has any questions, then please do type them in the chat box now, and we will address them when we get to the Q&A session. Now, I'm very pleased to introduce Irma, who's the Senior Business Analyst at the Helsinki Business Hub. Irma has over 20 years of international B2B business experience in all continents, creating international new business platforms to enable business growth from the Helsinki region in Finland. So cooperating and networking with large organizations, government organizations, investors, and globally. Their focus is, as I said, global, from the US, Singapore, Germany, and China, and the industry focus mainly in smart and clean technologies. So over to you, Emma, for your presentation on the innovative digital tools for built environment and international cooperation opportunities.
Thank you very much, and thank you for Emirates Green Building Council and Business Finland for inviting me as a speaker. I'm going to talk you briefly today some strongholds of Finland and what are the current trends. Then we have a short introduction for Singapore and activities, what we have been doing recently there. And finally, what kind of piloting and international cooperation opportunities are also in Helsinki and Finland region. Please, next slide. Can you? Okay, thank you. So first, to tell a little bit about Helsinki Business Hub. So we are international trade and investment promotion agency for the capital of Finland. So we help foreign companies to set up their businesses, grow and develop in Helsinki, and also find partners. We also fill some of the technological gaps abroad. So for example, if you have some needs in the indoor air quality, you can always approach us and we will try to find you a company to serve your needs. Because we are a public organization and owned by the city of Helsinki, our services are free of charge. We work with all foreign and local companies, investors, public sector, academia, and science and high-tech parks. So basically with the whole ecosystem in Helsinki and Finland and also globally. Next slide, please. We mainly work in three different areas, ICT, smart and clean, and health. But if there are needs in other sectors, we are happy to serve there too. But proactively, we work in these sectors. I'm specifically working in the smart and clean industry and have had special focus in the smart building, smart city applications the past 4 or 5 years. Next one. And how we can help you. So we serve companies with information, connections, business opportunities, and even piloting opportunities in Helsinki. Investors, we have about more than 1,000 companies in our investor register, which are looking, they're Finnish companies which are looking investments in different sectors, also in building, smart building area. And so if you wish to invest for Finnish companies, you can always contact us and we are happy to give you the deal flow for the companies and match make you with the companies. So we do tailored services for investors and companies according to their needs. Also startups, we help to find connections to the international investors and startup and investor events in Finland. Next slide, please. So let's go first for the Helsinki, Finland, and I want to introduce you some of the strongholds in Helsinki and what are the current topics which are interested in the Finnish economy and Finnish government. Next slide, please. Yes, we already heard from Aimo's presentation that we have a very challenging place in Finland. So we are from -39 to +33. These were the records in 2019. So I always say that Finland is a good testing environment. So whatever is your product, this is the good place to test because you will have the harsh winters and then sometimes +30 degrees, which is pretty exceptional in Finland, but 20 is probably more the summer weather. So next slide, please. Interest areas and trends in Finland on the next. So there's a lot of focus in smart cities, smart mobility, smart buildings. Smart buildings, of course, includes anything from sustainability, energy efficiency, indoor air quality, and so on. Sustainability as overall subject in all sectors is also growing very much. Carbon-free issues, digitalization as a big topic in Finland in all sectors, energy efficiency, and circular economy. Why I mentioned these are normally the ones which also government is also giving financing when you have your company registered in Finland. So there's a financing available for those sectors. And Finland is of course very well known about the 5G, 6G technologies, quantum computing, cybersecurity, robotics, and battery technology is also raising. Next one. And we rank, as we heard from Aimo's presentation, that of course we are the happiest country in the world, but there's also most innovative ecosystem in Helsinki, and the digital performance is best in the Europe. Next one, please. Why the digitalization has been very important in Finland. About 5 years ago, Finnish government put a lot of money to raise the digitalization of the built environment. So there was a Kiradigi experimental program where I would say the whole construction industry, anything from R&D, cities, companies, participated. They ran over 140 digital experiments with almost 600 organizations. So this kind of gave a good leap to the digitalization of the construction sector. And this has been also continuing with this was the Kiradigi project was the name of this first 3 years project. And this is continuing in a Kira hub, which is based in Helsinki. They still accelerate the development of the digitalization of the building sector. One very important thing, of course, in the digitalization is that securing data sharing between the stakeholders. And I think indoor air quality is one data, what we definitely want to get connected to all other data from the buildings and so on. Next one, please. Helsinki also puts a lot about the digitalization. It's not only that we do digitalization because of the digitalization, but the aim is to help people's everyday lives easier by giving services through the digitalization. Next slide, please. There's also projects going on a lot in the mobility area, like robots, buses, and drones are tested in Finland. There's a Vim mobility app which kind of connects all kind of mobility issues in the single app and helps to find the right way of moving around in Helsinki. Next one. And what is needed to be able to digitalize the society? So of course, open data is quite in the stronghold there, that you need to be able to use the data to develop the digital services. Cybersecurity plays even increasing role because we are all the time in the web, in the internet, and so on. So Finland has the strongest cybersecurity cluster in Europe. And then as a Nokia heritage, the great mobile dev is know-how. So wherever you move and go on, you will be connected by your mobile phone, whatever is the digital solution. Next one, please. And I also want to mention this circular economy thing. This is also growing a lot, and also in the construction field. There are special projects going on in Finland where are looking how you could increase the circular economy also in the construction area. Helsinki also puts a lot of effort for there. So we definitely want to bring the environmental issues to the whole area, and not at least in the construction sector, by digitalizing it, by doing circular economy things, and so on. Next slide, please. And now I want to open up a little bit what happens in Singapore with us. We have been cooperating with Singapore about 5 years now, starting in 2017 when Finland came 100 years old. Next slide, please. So some trends, what has been found in Singapore, including also the building sector, is of course the environmental concerns, sustainability, and carbon-free issues. Cities inside cities has been also growing during the COVID time because, as we all know, Singapore is very densely populated. So they want to avoid people to go around like infected during the COVID time. So try to build the services digitalized or physical services close to your place where you live. So the cities inside cities is also growing, and there are some projects going on in Singapore in that one. And digitalization has been one of the major areas also in Singapore to proceed in that sector, and definitely robotics. When if there's a lacking labor in certain areas, they prefer to use robots when available. And I mean, indoor air quality has also been raising as a topic in Singapore, and we had the event, first event a year ago in Singapore in that topic. But please, next slide. And if you compare about Finland and Singapore, it was already mentioned that we are about the same population, the countries. Singapore is a little bit smaller than Finland as a land size. So in Finland, we do have a lot of forests and lake sites and so on. But what is quite common for us, we both rank very well in the Smart City Index. And as Aimo stated in his presentation, I think the indoor air quality is also could be part of the smart city ideas, or closer for smart buildings, because of course the effects of the indoor air quality is also what happens outdoors and then indoors. Next slide, please. And if we look about a little bit about the energy consumption, electricity consumption in buildings, between what is the difference between in Finland and Singapore, and I think I believe that UAE could be close for the Singaporean ones, that you do use a lot of energy for cooling of the houses. In Finland, of course, it's the heating of the houses. But when we look about the lighting, we are about the same level, and then also, of course, there are a lot of high rises in Singapore and UAE. Then, of course, lifts will use a lot of energy too. But I know that the saunas are not that much energy consumption in Singapore or UAE, but we do use 5% of the energy for heating of saunas in Finland. And I mean, for the 5.5 million people, we have over 2 million saunas. So every family has at least one sauna. Next slide, please. We have been working a lot with IPI, which is a government organization in Singapore. They do track technologies around the world and wish to matchmake companies around the world. They are very active, and they have been our first cooperator since the last 5 years. We have arranged a huge amount of mini seminars with them in different topics, and also we have enabled piloting also in Singapore and together with IPI. Next slide, please. Some examples about cooperation. I already addressed this, started 2017. How we have been working there, we have arranged a lot of mini seminars inside companies, larger construction companies, real estate companies, government organizations, and so on, where the focus has been according to the customer needs. So anything from energy efficiency to digitalization to indoor air quality. Last year, we had this first seminar in indoor air quality solutions together with the IPI. And it was also very information sharing from both sides. So Finnish solutions were introduced for the Singaporean government, and then some R&D work, what happens in the Singapore, was opened up to Finland size. A little bit similar like what we do today. And the recent one, we had a larger event this year, was about the plastic recycling, also including some new innovations in the construction field, like houses made about totally recycled plastics, mainly for developing countries, but anyway, quite nice Lego house in a way to serve the areas where they are good. Next, please. And I already addressed that indoor air quality is really, really important. Of course, we are about 90% of our time indoors. Next slide, please. And one additional thing, what I also want to mention, that we talk about the VOCs, PM particles, and so on. And sometimes we forget that the outdoor impurities are in a big role also for indoor air quality. Sometimes people believe that when you go inside, the air is better, but actually it could be even worse. And one additional feature which has come into the picture, of course, it's a COVID-19. I mean, viruses have been always around with us, and hospitals are very good at handling them. But sometimes we even have to consider that how to clean the meeting rooms, how to clean the places, how well we need to ventilate if we get infected people around, because sometimes they don't have symptoms and we don't know what they are. So that has kind of brought one more parameter for indoor air quality to be considered. And of course, ventilation rates and tightness of the building are the very basic things in the indoor air quality. Next one, please. And I think what needs to be think about the indoor air quality, that you have to think about that during the whole life cycle of a building. We were seeing in the first presentation about the regulations and standards in indoor air quality. Of course, that is an issue that you need to take an account. Other issue is who is in charge about the buildings. I see sometimes in China that if you are living in a rental apartment, if you wish to have a good indoor air quality, you need to just buy the standalone unit inside your apartment. So necessarily the house owner doesn't put effort for the indoor air quality. In Finland, we have quite strict regulations about when the new house is built, that what is the responsibility of the builder for the first year, for the 10 years, and so on. So if there are any problems in the indoor air quality or the ventilation, we can contact the main contractor and ask for improvements. But I think one thing which is growing all the time is the data management, overall data management and IoT solutions, and throughout the whole life cycle of building. And even here, like digital twins would help. We would know what kind of sensors have been installed, when they are serviced, and so on. So I think it's not something which we can forget when we have installed it, but we just would need to think about throughout the whole life cycle of the building. So during design, construction, and even operational and maintaining, and even cleaning the ducts for the certain time. So it is a whole lifetime process, and the better the data can be shared, a link for indoor air quality, the better it is. Okay, next slide, please. And here are some examples about Finnish companies which work in this field. We do have air quality sensor networks, cloud service and measurement suppliers. Then some other innovation solutions and tools here are mainly data management and some questionnaire things linked for also any subjects, and then indoor air filtering and cleaning solutions. So Finland has a very, very large know-how and a large industry in the indoor air quality. Like I must say that they are research organization. They are happy to research. I'm sure that these companies and some others too, these are not every company mentioned here, but they would be happy to cooperate with the projects to improve the indoor air quality situation in your country. Next slide, please. And then, of course, what is good with Finnish people? Finnish people and the Finnish companies are really reliable partners who stick on the contracts and deliver at time, and they are able to do the world-class indoor air quality solutions. Next slide, please. And last slide about the Singapore cooperation. What we have had, we recently started a cooperation with Smart Urban Co-Innovation Lab, and where we also look about different challenges in the smart cities and so on. So we want to be like a gateway to Europe in Finland, and the Singaporean organization, which has a CapitaLand and IMDA organizations behind, they are also want to be the one towards to Singapore. Next slide, please. And now I also want to have a quick run to City of Helsinki as a platform for new innovation. So what kind of international cooperation possibilities is available in Helsinki? Next slide, please. Helsinki has recently opened a web page called TESTBED.HELSINKI. It is an opportunity for companies to come and test their issues in the real life environments. So the companies can suggest to City of Helsinki that we would like to do this trial, and then the city will decide if they accept it or not. Sometimes there are like innovation competitions in there, but it is free for any time to contact, and the built environment is one topic there. Next slide, please. Also, when I started my presentation, I talked about the open data, and open data is available for any application suppliers. So if you look about the constructed environment, there is about over 100 open data available in that topic. So if you are a supplier for those things, there would be a possibility to come and test and use the real data gathered from the city. Next ones. And I've run very quickly through. So some areas of the development in Helsinki. Pasila is one of the areas where detailed 3D city model is used and digital twins, and also 5G network. So this is the place for test these and work with these. And this data is shared with the construction companies and projects. Next slide, please. This is the picture of how Pasila will look in future. Currently, there is the lower buildings already existing there, but the high rise is not yet started. Next one, please. Kalasatama is the smart district in Helsinki, which has started a lot of agile pilots. It will finalize the project this year, and they will spread all around in Helsinki. So the main thing in Kalasatama has been this public-private people partnership. So all the society have been attending, the citizens, the R&D organizations, companies, to run different kind of trials there, from smart mobility to smart buildings and all in between. Next one. Next, please. And Maria 01 is the one which offers the ecosystem for companies to come and work together. So there are startups, there are investors, there are larger companies. It is the leading startup campus in Nordics, and it wants to be the European leader in 2026. It already has over 200 companies in there. Next, please. And Otaniemi, there is also VTT Research Center, which I was representing. There is also a lot of energy-related development sites where people can participate. Next one. And Aalto University, of course. And last but not least is the Jätkäsaari, which is the modern urban district where mobility kind of applications are tested. So smart mobility piloting in here. And the last slide, please. Okay. And sorry, can you just go back to the car? I just want to say there is a sweeper, robot sweeping the streets in Helsinki. This is the newest robot in Helsinki region, which actually cleans the streets in the night. It's still on pilot phase, but I think it's a fancy looking cleaning car for the streets. Next slide, please. So I'm happy to help you. Next, if you need any question, if you have any questions. We have also recorded podcast about cities and businesses and how is life in Helsinki. And we wish to build sustainable Helsinki together with you, with your solutions, sharing our solutions, partnering, matchmaking you with the Finnish companies. And there is also short video about 100-year-old building, which was brought to this time as a digitalization. So thank you very much. I hope you enjoy it, and feel free to contact me anytime for any questions of the industry or the piloting opportunities. Thank you.
That's great. Thank you very much for the presentation and sharing some of those really great examples during your presentation. So, okay. Our next speaker we have Dr. Antti. So he is the head of the research group Aerosols and Climate at the Finnish Meteorological Institute. He's an adjunct professor for experimental aerosol physics and has studied atmospheric aerosols since 2002. So in addition, he's participated and led FMI's development of collaboration programs, for example, relating to air quality and climate research in India. So in 2020, his group joined into an interdisciplinary collaboration on COVID-19 research, which looked at an experimental virus simulation study conducted in a real restaurant setting in Helsinki. So very excited to have you with us today, and I'll hand over to you for your presentation.
Thanks a lot, Lindsay, and thanks a lot for the invitation to present here. Could we have the next? Okay, I can control it as it seems. So first of all, what I'd like to say is that this is by no means a study that has been conducted by us alone. As was stated by Lindsay already earlier, that this is an interdisciplinary study together with Helsinki University Hospital, University of Helsinki, and then Institute of Occupational Health. And actually this study that we conducted was funded by Business Finland, who is also a co-organizer of this webinar today. A little bit about my background and where I did my experience and obtained my competence as an aerosol researcher was basically in India, where we studied aerosols and air quality and learned how airborne transmission of pollutants actually travel. We all know that in low-lying areas in Indo-Gangetic Plains and in big city like Delhi, we have a severe air pollution problems. But actually what we found out, we had a measurement station in the foothills of Himalayas in a tiny hamlet called Mukteswar, and where people thought that the air is always clean, but this was actually not true. And because of the small aerosol particles that were generated in the low-lying aerosols were actually migrated and transmitted all the way to the pristine Himalayan environment. And in the picture there where you see the Himalayan peaks, it's actually a live picture taken from Mukteswar, and basically on the mid-level there you see a sort of a brownish haze, and this is the aerosol pollution layer that is residing there and clearly visible in the picture as well. Okay, so we started to discuss with medical doctors and virologists about the possibility of different transmission routes of COVID-19 when the situation arose about 1 year ago. And typically what we learned was that there is this threshold of 5 micrometer particles were bigger than that are called droplet transmission, which is the sort of the conventional way of viruses, respiratory viruses transmitted. Basically, when you sneeze or cough, there will be big particles coming, and that's why it's the recommendation of 2 meters of safety distance, that these big particles wouldn't reach the breathing zone of the other person. But then there's the aerosol transmission that traditionally was said to be 5 micrometers, that actually these particles, they go along, especially in indoor airs, very similarly as I saw in the previous picture, the India example, that they travel far and they can linger in the air for a long time. And then there's also surface contamination because of course these droplets fall on the surface and can even be resuspended from the surface. But actually from aerosol physics point of view, discussing with the doctors, we said that we don't really understand where this 5 micrometer limit comes from, because in our experience, this should be maybe closer to 50 micrometers. So, which means that in our understanding, there's quite a big of aerosol volume that can be transmitted in indoors air and can pose a real problem in different kind of virus transmission. So we decided to conduct a study together, and the aims of the study were so that we wanted to simulate airborne virus transmission indoors, and we wanted to use a real virus for that. And we had experts at the University of Helsinki microbiology department who had very big experience in working with this kind of viruses, surrogate viruses, and selected us a virus called 5.6, which is a bacteriophage of a bean, and so it's completely safe for humans and completely safe for this kind of action. And we wanted to spread it in aerosols and see if the virus actually survives and if we can detect it with different methods in a restaurant. And in addition to that, we wanted to develop a supercomputer model that we could test for safety solutions that will allow better control of pandemic safety in the future. And the underlying motivation of all of this was that we wanted to develop different kind of safety concepts that could help restaurants and other public environments to remain functional during a pandemic, so that you wouldn't always need to shut everything down, rather than shut the necessary parts down or use different kind of safety concepts so that you could keep things open. And we collaborated with the famous Finnish chef called Henri Alén, who kindly led us to do these experiments in his restaurant in Helsinki. So what is the model virus 5.6? And now our virologist Nina Atanasova has put together this nice slide that is comparing the 5.6 virus with the SARS-CoV-2 virus. And you can see that they are very similar to each other. So they have the same kind of size. They are roughly 80 nanometers in diameter. They have the similar kind of spike complexes, and the surface structure is very similar. So this is a very good surrogate virus, this 5.6, to simulate the SARS-CoV-2 in a safe manner. So what we did in the restaurant is that we used a medical ultrasonic nebulizer producing virus-laden aerosol, which then simulated that there's a infected person speaking or breathing in the restaurant. And this ultrasonic nebulizer, we measured the size distribution of particles that are coming out of that, and verified in that nebulized aerosol size distribution is very similar to that of typically respiratory emitted aerosols. And the restaurant, which is called Ultima in Helsinki, was about 60 square meters in surface area, and then we actually nebulized a very high concentration of the 5.6 solution in the air, very much bigger than what you would typically get from, let's say, a sick person, but this is needed, of course, in our measurements, because what we wanted to see is a kind of a proof of concept and actually measure and see what happens in the aerosol, and with real concentrations, actually you are not able to do it. So this is the best and only way to do it. And then we measured both infective viruses and the number of all viruses, whether they are alive or not, from the restaurant. We did active air samplers, different kind of aerosol samples were taken, and then passive deposition samples, so petri dishes with virus host and soft agar layer where the viruses could be deposited, and then also surface sampling by swapping samples and directly with either a cotton swab or then with a finger. And there you can see the researchers in the restaurant during a simulation day when they are working with the samples. And then the other method that we did utilized was computational modeling. And the method that we used was a large eddy simulation method, which is a computational technique for accurately resolving fluid flow. So basically, it simulates the air currents going into the room. You need to first make your measurements of the ventilation, where the air is coming from, where it's going to, what are the temperatures and pressures. And so we did that. And then what you additionally need is a supercomputer, because this LESS method is computationally very heavy. But there you can see an example in the picture of a simulation situation. And if you are wondering what this sort of a ridge there means, it's actually ornament hanging from the roof of the restaurant. Then we go into some of the results that we obtained from the study. Okay. So first of all, what we wanted to see was a proof of concept whether the virus actually stays viable and how far it travels in the restaurant. And here you can see on the left-hand side 2D map looking from above of the restaurant. And what you can see, if you can see my cursor now moving, there is the nebulizer. So here is our sick person sitting on the top right-hand corner. And this is where we nebulized for simulating a real dining event. So 90 minutes the nebulizer was on, and we wanted to see how far do viable viruses travel. And on the table on the right hand side, I've selected now some data from our measurements that we did. And first of all, you see there table A, table C, table D, and so on. And you see two different times. First, the duration. So when we took Petri dish after this 90 minutes of dining, and you see that actually living virus, which is now in the very right hand column there, called PFU, plaque forming units, that were there on the Petri dish. You can see that on table A, which is very close to the nebulizer, we have too many to count, so basically means that Petri dish was full of virus. Table C about 400, chair D about 600, and if we go down to the list and we go all the way to the bottom left-hand corner of the map, you see couch M about 103 plaque forming units on the Petri dish. So this was a very strong evidence that the virus does not only spread in traditional, let's say, coughing and sneezing, and the 2-meter safety distance would be enough, but it also spreads in aerosols and all the way to the other side of the restaurant. So that is sort of the bad news. But what is the good news is that we took also samples 30 minutes after turning off the nebulizer. And now if you see the same numbers, table A, table C, chair D, you can see that the plaque forming unit concentrations have decreased dramatically. So the ventilation in the restaurant is so good that only after 30 minutes the sick person leaving the room starts to be not a risky environment anymore. So then we tested different kind of safety solutions. And now I have here mean aerosol number concentrations that were measured with if you can see here on the right hand corner again a fraction of the map of the room, you can see here APS1 was our first aerosol instrument, and APS2 was our second aerosol instrument. Sorry about clicking that. And then you can see here on the right, on the bottom, you can see 3 graphs with different kind of safety solutions for using air purifiers, using space dividers, which are basically like plexiglass, or using a combination of the both. And you can see that before the reference or the intervention, our concentrations are actually very low, so we are pushing a lot of the particles into the air. During the reference simulation, so when we don't have any purifiers in the room, you can see the concentration of APS1 and APS2, and then during the intervention of the purifiers, the concentrations have decreased maybe 25% roughly. And then if we use the space dividers, the same thing in the reference simulation and in the intervention, and you can see that for the APS1 we actually have a higher concentration, which is sort of expected because it is in the very vicinity of the nebulizer, but the APS2 doesn't really have any kind of visible action going on there, so there is no decrease of the concentrations. And the combination gives very similar results to the dividers alone. So then we come to the computer modeling results, and these are very high resolution, and I would say that they are state of the art in the world. Nobody can do it better at the moment than what we are doing, at least for this kind of a live case, and we built our capacity to do this kind of modeling during the project very much. And now on the left hand side you have a reference simulation and aerosol concentration in the restaurant 8 minutes after the infected person has entered, and you can see that this kind of a cloud of the virus has been starting to spread. And the same simulation 8 minutes again, but now with the air purifiers on, we had companies also in the project who delivered us their purifiers, and we used so that these purifiers added 60% compared to the typical ventilation rate in the room, and they also mixed some of the air. And what happens is that you can see a little bit lower concentrations occurring, and you will see it even more so in the next pictures that I will show. Then the plexiglass dividers, you can see that there's basically no effect. So the aerosol particles, they go above, they go around, they find their way with the air currents to go around these dividers. And actually what happens even more so is that they create a sort of pockets of high concentration within them, because the air cannot mix inside this sort of cubed plexiglass environment. And if we use both plexiglass and these kind of air purifiers, then the situation is a little bit better, especially in these cubicles that are not right next to the infected person. We also did a probability of infection analysis, and now this is not based on our measurement or our emitted virus, but it's based on literature values of what a person can emit of the virus and what would be the infective dose. And I have to say here that these numbers, they are still highly uncertain. So there's a high uncertainty both in how much a person emits virus, and there's a high uncertainty what is the infective dose. But literature values exists, and that's basically what we now used. And now on the left-hand side corner, you see actually from the top the restaurant setting, and now this G would mark the point where we had the infected person, and this infection probability is after 30-minute period of staying in the vicinity of this kind of person. And you can see that right next to him the probability would be about 30%, and then it would decrease but still be non-negligible in the other side of the room, verifying our experimental findings as well. And then I add here 3 pictures more, and now actually what is here is the difference between these safety solutions and the reference case, meaning that if you see a blue color, that would mean that you decrease the infection probability, and if you see a red color, then you actually worsen the probability of infection. And the first picture here is the reference with the air purifiers, and you can see that there's some air maybe going the wrong direction, so to say, but most of the room you see blue color, which means that we can decrease the risk of infection up to 20%. And then if you use the dividers, the situation is worse. So you can see these, you actually worsen some of the situations in the next cubicles having the red color. And then if you use both combination of that, then the situation is kind of a mixed. It's not quite as good as the air purifiers alone, but it is way better than using the dividers alone. So the air purifiers, they improve mixing and ventilation, but the capacity must be sufficient, and space dividers alone cannot be recommended as a safety solution. Conclusions from the study is that with properly sized air purifiers, the infection probabilities can be reduced significantly. And we found that both mixing and filtration are important. The mixing dilutes local concentration and enables outlets to remove pathogens earlier. And then the filtration in the air purifiers reduces concentration, particularly after long time spans. And alternatively, you can ventilate. In Finland, it's easy most of the time, especially this time of the year, we can open the windows. I understand that this is not possible in hot countries, or if we go back to my first slide, India, where the concentrations of outdoor pollutants are very high. You don't want those to come inside. So basically we need technical solutions so that we can ventilate safely our indoor environment. And Aimo, of course, presented these in his very first presentation. Now, final reminder that there were plenty of interdisciplinary actors participating in the study, and the financing was done by Business Finland. So thank you for your attention.
Thank you very much for sharing that presentation and your research with us, the audience. So I would like to now invite back all of our speakers to take some questions from the audience. We still have a little bit of time remaining, so if you could all just turn your cameras on. Welcome back. So again, thank you very much for joining us today on this platform. So what I would say to the audience, if you have any more questions that you would like to ask any of the speakers, then now is a great opportunity for you to submit them. You can also continue to submit your questions after the webinar, and we will get back to you. So I'm actually going to start to kick off the discussion, and I've got a question for Irma. I wanted to know, you work with multiple markets across the globe. So what are some of the best practices you've seen from these markets in improving IAQ in buildings? And was this mostly mandated by the public sector, or are you seeing leadership from the private sector?
I think there is not such of one thing like a best practices, because it is quite a large topic like indoor air quality, and it affects I mean, everything starts from the recommendations and regulations and standards what exist in every single country. These might exist, but nothing might happen. So it is kind of a egg and chicken problem that when the people start to talk about that, make the indoor air quality better and make us environment healthier, I think then the reaction grows larger. But what I already addressed during my speech, that some places it is according to the people who are living in the apartment, that they have to really take care about the indoor air quality by themselves. And then some other countries, the construction company is really responsible of taking care about that. So I think it's a large question, and as long as nobody, let's say, constantly measures the indoor air quality in the buildings, it's hard to say that that is good or that is bad. Of course, you can get these sicknesses by the people and so on. So I think the overall development is still on the way. There are regulations which say ventilation rate and VOCs and so on needs to be done, but very seldomly they are controlled unless there is some, let's say, not so nice event that people get sick or so on in the building. So there are not really many. I don't know if Aimo knows better. He has been in this research field longer and knows the global thing, but I think they're still about to obey the regulations, to follow the regulations, and even monitor the indoor air quality constantly. And that is the trend, what I see, that there's a lot of companies coming in which do have the solution for indoor air quality. So it is constantly monitored, and then it's shown if some values are exceeded, and that of course helps to keep that good level. So I would say that the overall solutions are developing, which is a good thing, and I hope this is this can be pushed from the government side, this can be pushed from the construction industry side, but in the whole globe is not happening meantime, unfortunately. But Aimo, if you wish to add something about this, you might know it better. But we know that there are different filter technologies which are better than the others, like Aimo already showed in the electrical filters and so on. But it adds everything. So it is about the materials what you use in building, it's about the ventilation rate, it is outdoors, indoors, and then how you maintain the house. So to put all this together is a little bit hard.
Yes, I think the same way. I think that you need a comprehensive solution. So you need to take into consideration all of these aspects, because if you are starting to willing to solve the problem with only one technology, you will probably not receive the best solution. So it's important to have this cooperation as widely as possible.
That's great. Thanks for sharing and kind of picking up on this theme. Emma, I'd like to ask a little bit more about your experience of the public and private sector collaboration. Can you share with the audience active collaboration between research and institute, building consultants and designers? How can this result in practical solutions for improving indoor air quality within the sector?
Yes, I think it's very important question, and I see that in many cases the best lessons we learn in real life. So that's why I think that all demonstrations and pilot projects, they are very important. And as I said, normally it's not worth doing this kind of efforts alone, because it's important to cover all these areas. And what comes to this public and private partnership, I think that if you arrange this pilot in such a way that you have participants from both the companies who provide the technology, and you have some research institutes, scientists who can actually measure the performance in long term in real environmental conditions. So you get valuable results, and the results are kind of proved by some independent research organization, and they are scientifically valid results. So it creates more value if you are able to show that, okay, if you install this and this and this and measure this and this and this, you get this kind of results, and the customer can rely on the result because it's confirmed by this, let's say, academic world. And then maybe afterwards it's possible to even put in some common journal article or conference presentation. So it's possible to kind of bring the message forward and disseminate the results also in scientific way. So of course it's important in commercial way, but we can do it also in scientific way. And maybe one more thing is that perhaps it's good if you can also involve some of your good customer who keep asking, do you have something new? I would like to try this and this and this. I have seen that these kind of companies, they are interested and they are willing to give the premises for this testing, like Antti mentioned, this Finnish restaurant. So I think it's very valuable if you can get this real environment, and you get also the support from the end user. So basically you can build this holistic approach, and you get feedback from the users and things like that.
Thanks. Yeah, no, I completely agree. But when you talk about the holistic approach, there's definitely a role for, you know, the private sector, academia, and government really in kind of improving the indoor air quality and then tailoring solutions here from the UAE. I've now got a question for Dr. Antti. So there's been a lot of research and on the historical increase of greenhouse gases and the effects on global climate. However, studies on the historical effect of air quality, especially from human activities, is not as widely known. So why do you think this is the case? And can you maybe share some insights from your work on the trends and effects of human activities on air quality?
Thanks, Lindsay. Maybe the main motivation is that we know from science that CO2 is the main culprit behind the climate change. But the other reason is that the level of understanding and of the scientific understanding and level of experimental measurement methods for air quality and aerosols in particular has been much lower and hasn't been there for similar long time as for the CO2. So the observations don't exist that far back. And what also is part of the reason is that these aerosols are so-called short-lived climate species, meaning that you need to, they go away from the atmosphere very quickly, so you need to be there to measure them. And we actually don't know very accurately what the aerosol levels were before the industrial era, which is the typical reference point for considering climate change. So what we need basically are long-term observations, and we need them from good coverage both temporally and spatially. And actually that's something that is what we do at the Finnish Meteorological Institute, and many researchers, atmospheric researchers from Finland are highly cited in this area, especially Professor Markku Kulmala, who has the idea of establishing 1,000 measurement stations around the world for exactly this kind of a reason.
Okay, that's great. Thank you for that answer. And we've got some questions coming in now from the audience. So one of the topics which is being raised is that indoor air quality is affected by many different pollutants, routes of entry, and has different effects inside the household. So we've got a couple of questions asking about, when it comes to kind of government regulation and kind of monitoring, what can be the focus that the governments can have in terms of their regulations? Where should they be focusing to help kind of monitor and put in place regulations for indoor air quality?
Yes, so if I may start with this one, I think that we need, of course, regulation for ventilation rates, that they are big enough. And I think that also some rules for efficiency of the supply air filters, because especially for particles, because based on this WHO and some epidemiologist evidence, the particles is the main environmental risk. So that's why I think that these particles should be considered, of course. And I guess that filtration is one way to do it, and it's better to kind of put the limits in such a way that you give the ratio of the concentrations indoors and outdoors, because it's not so easy to guarantee any certain level of concentration indoors, because the concentration outdoors can vary a lot and during very short period of time. I'm sure that Antti has much experience on this one. So it's better if you define it by this indoor-outdoor ratio. And then maybe the third one is more like related to this materials. So if you have a very high emission rate from wall paints indoors or things like that, so maybe the gaseous components concentration might be too high. For example, formaldehyde from certain furniture can be a problem. So these materials has to be guided somehow. And maybe from energy perspective of view is that maybe the leakages of the building envelope should also be regulated, so that you can control the routes of the air coming in and going out. So you can install the filtration in this route, and it also enables you to use this energy recovery systems, because if the leakage is uncontrolled, so you can't clean the air and you can't recover the energy from the leakages also.
Maybe I can add to Aimo's words. I fully agree, especially with measuring the fine particles and the aerosols. And when it comes to this sort of COVID-19 era, then one of the sort of the measurements that has been proposed is measuring the CO2 levels as an indicator of the let's say, possible pathogens in the air from respiratory viruses, because the CO2 very highly correlates with the number of people residing indoors together with the ventilation rate. So it's a sort of combination of these two points. And actually, as I understand, in Belgium, in public places at the moment, they have set guidelines that they should all contain CO2 meters in visible places, so that people can judge by themselves whether it would be safe at the moment to enter the buildings or not.
Yeah, great. Thanks for sharing. And I think there really is a lot happening in different countries across the globe. So there's a lot of best practice and learning which can be captured and kind of transferred here to the UAE. So I'm very conscious of time. I think thank you to all of you for providing such excellent presentations, really highlighting some of the expertise, research and organisations working from Finland. I'm just going to sum up with one final question, which has come in from the audience, which is just really, if as a kind of takeaway from this, can you talk a little bit about how can Finnish companies support us improving indoor air quality here in the UAE? So I'll add that to put that out to all the speakers, just to kind of sum up before we close the webinar.
Okay, so if I just start, as I think all Aimo and Antti and myself addressed that there is a long experience on the indoor air quality issues in Finland. So there's a lot of know-how in there. And I'm sure that it doesn't matter if it's an R&D cooperation or purely commercial cooperation. I think the Finnish people would be delighted to help work together. Of course, I always believe that there has to be a local know-how, so a good partner in the country wherever you are working. So I guess the question is back to you, that where you wish to work together with the Finns, and we would be happy to matchmake with you with the right organizations or the companies, that where is the, let's say, the largest gap currently where you wish us to be helping. I'm sure we will be happy to do that.
Yes, exactly.
Okay, any
exactly
additional?
Same words as Irma, and I think that the Finnish people, that collaboration is somehow built in us, and we are very, very happy to do so. And whether it's research or whether it's companies.
Yes, I agree. And as Irma also mentioned, that we have this very high quality know-how in Finland, and I would like to bring up some areas. I would say that we have many companies who are really good in particle measurement technology and gas measurement technologies, and they are really forerunners worldwide. And I think we have also some filter companies or air cleaner companies who are quite good, and they are used to get very high efficiencies. They are much higher than what is the regular level. So there is quite a big step to take if you want to really to improve this indoor air quality. And maybe the third one is this energy recovery system, because it's especially during these pandemics, it's important that you ventilate. And the ventilation is to exchange air between indoors and outdoors. So it's not to exchange the air between different rooms indoors. So you need to exchange the air from in to out. And of course, you don't want to use too much energy for that. And in that stage, I think that these energy recovery systems, which are integrated to air handling units, they are one question there. And maybe, of course, another solution is that to install this high efficiency filtration to recirculate in air. But I would also look at this energy recovery system as one part from Finnish companies.
Okay, that's great. Thank you everyone for summing that up. I think collaboration and cooperation is really the key word here. So I think you've highlighted some of the know-how and the expertise. So really, again, just thank you to all the speakers. Thank you to Business Finland for also partnering us on this webinar. And I think the final things to the audience is that Emirates Green Building Council are here to help facilitate your businesses with where you need support and make those connections. So if there's any further questions or anything you want to follow up with, you can contact Emirates Green Building Council on the email that's shown on the screen now. And also we can put you in touch with our contacts at Business Finland also, or you can reach out to them directly to see how we can foster some of these partnerships and collaborations, really with the main aim of improving the indoor air quality here in the built environment. So thank you all again, and thank you to the audience for being with us here today, and we will be sending the follow-up email after this webinar. So please remember to complete the exit survey, and thank you again. Thanks very much.
Thank you. Bye-bye.
Thank you.
Thank you.
Bye-bye.
Bye.